All right, last section of chapter 7, which is all about regular polygons. So what does it mean for a polygon to be regular? Well, that is just when all the sides and all the angles are congruent to each other. Okay, so we can think of our equilateral triangle or equiangular triangle as being regular because it has all the angles and all the sides being congruent. Okay, so we're going to be looking at a series of formulas here that only work when you are finding specific angle measurements of either regular or equiangular polygons. So that's really important to remember. Because if it's not regular or at the very least not equiangular, then these formulas aren't going to work. Okay, because it is based off of all the angles having the same measure. So let's take a look at the first formula. The first one asks us to figure out what is the measure of each exterior angle in an equiangular polygon if you have n sides. Well, we know that the sum of the exterior angles is 360 degrees. So if we take that 360 and divide by the number of angles, which is the same as the number of sides, you'll get the measure of each exterior angle. And we use a capital E to represent the exterior angle. Okay, so that's a pretty easy calculation to do. Next one, what is the measure of each interior angle of an equiangular polygon? Well, there's actually two ways that you can think about this. First of all, this is the method I personally choose over the other one, but if you think about it, if you have a polygon, I'm just going to draw some of the sides here, okay, I guess I could continue and there we go. Weird polygon looking thing. But you have your exterior angle here, and you have your interior angle there. Well, how do they relate to each other? Well, this exterior angle and this interior angle are supplementary to each other. So if we know what the exterior angle measure is, so if we know what this is, we can easily subtract that from 180 to get that angle. So that's this formula that says that the interior angle is going to be 180 minus the exterior angle, which we use this formula to figure out. Okay, so I think that's a pretty easy calculation. The other way of thinking of it is the same method that we thought of for Theorem 58, which says, well, we can take the sum of the interior angles, and then we can divide by the number of angles. And so if you recall, this is the formula to figure out the sum of the interior angles of a polygon. So whichever formula you like best, go ahead and use. You don't have to use one over the other. You guys get to pick which one feels more comfortable for you. Okay? So, oops, come on. There we go. Let's take a look at some sample problems. First one, it says find the exterior angle of a regular pentagon. So pentagon has 5 sides. We're going to plug that into our formula. 360 divided by 5, we get 72 degrees. So each exterior angle is 72 degrees. That's pretty easy. Okay, find the interior angle of a regular decagon. So decagon has 10 sides. So let's do this both ways and see which way might end up looking easier. So the first method is to take 180 and subtract 360 divided by 10, 10 coming from the number of sides. And so when we do that, we get 180 minus 36, which is 144 degrees. Okay, now if you wanted to do the other method, the other option would have been to figure out the sum of the interior angles and divide by 10. So that would be 10 minus 2 times 180 divided by 10. So when we simplify, we get 8 times 180 divided by 10, which comes out to 144 degrees, which we knew it would. So you just look at these calculations and you decide for yourself which style feels best for you. Okay? All right, now what we can do with these formulas is we can actually solve for the other in the other direction. So they can give us the measure of the angle, and they can ask us to figure out how many sides they have. Okay, so here's some examples of that. It says, find the number of sides an equiangular, and they have to give us that at the very least, maybe it's regular, but equiangular polygon has if each exterior angle is 30 degrees. So we're going to use that formula for the exterior angle, but instead of plugging in n, we're going to plug in e. We plug 30 in for e, and we're solving for n. So we can do a little cross multiplication here and get 30n equals 360, so n equals 12. All right, so here's a bonus question for you. What's the name of this polygon? So if it's 12 sides, what would that be? You probably are saying it's a dodecagon. Well, you have to be really, really careful because you have to call it an equiangular dodecagon. Okay, so equiangular dodecagon. If we just said dodecagon, this would not work because we wouldn't be able to use this formula. Okay, so watch out for that. Next, it says find the number of sides an equiangular polygon has if each of its angles is 135 degrees. Okay, so once again, now you have to make this choice. Which of the two formulas do you want to use? I'm going to use the one that I like best. And I'm going to replace I with 135 degrees. So I take 135 equal to the 180 minus 360 divided by n. And so I'm solving for n. So the first thing that I want to do is I'm going to subtract this 180 from both sides to get the negative 45 equal to the negative 360 over n. And I know that these two negatives are going to cancel out, and then I can cross multiply. So I get the negative 45n equals negative 360, or you can say 45n equals 360. And then you divide and you get n equals 8. So that means that it has 8 sides. What would the name of that polygon be? Hopefully you are saying an equiangular octagon. So on your test, you will have to be able to name the shape based off of the number of sides that you're solving for. And if you are using one of these two formulas, you make sure that you put at the very least equiangular in there. And if we don't know anything about the sides, we have to just say equiangular and not regular. Because yes, there are equiangular polygons out there where all the sides are different. Think of the rectangle, which has 4 right angles that are all congruent, but the sides are not. So we do have to watch out for that. Okay, so there you have it, another section full of formulas and lots of calculations. Hopefully that'll be fun for you guys.